And this is the Cascade River that winds down in between all this. Next project that we want to talk about is the Dunvegan project, and this is one in Alberta. And this is one that I was referring to earlier with 11 years to get through the regulatory process. And this is a very unique concept, one that I came up with in looking at why can't we build hydro on main rivers today. And we identified 5 major criteria as to what are the major hiccups to getting regulatory approval for projects. And we decided to design something that met every single one of those requirements. And in fact, they didn't know what to do with us because we didn't meet any of the thresholds in a lot of the environmental jurisdictions. So they sort of invented stuff for us. It's 100 megawatts. It's only 7.6 meters of head, and it's 1,800 cubic meters per second flow. And what makes this project unique is that we have the WAC Bennett Dam in BC, which holds about 1.5 years worth of flow for the Peace River. To give you an understanding of the Peace River, it's 1/2 kilometer wide, 5 meters deep, traveling at 5 meters per second. That's a lot of water, and that reservoir in BC holds up 1.5 years of that volume. So it's a fully regulated river, and that means that instead of it having a normal hydrograph that is low in the winter and high in the summer, the river is more or less constant now. And that was done some 35 years ago. So we thought we'd capitalize on that. Having a nice even flow throughout the year means that we can build a 100 megawatt base load facility. And that means that it's a coal-fired thermal plant replacement, is that base load, or whatever the case may be. And that was the concept behind that, the fundamental project. So there's the Dunvegan Bridge across the Peace, and that we're at a site about 2 kilometers upstream of that. This is what the river valley looks like from the bridge. And that's what we're proposing across the river. And it's basically a weir. It has 40 turbines inside of it, and the powerhouse is fully overtoppable. So we have the weir in Calgary, down in the middle of Calgary right now. They've done some rock work around it and so forth. We're doing very similar things with our bypass channels and our fish channels to go around this structure. And the idea of this is that we would have full passage upstream and downstream of fish with 0 interruption or mortality. That was our goal. Designed a brand new turbine that had never been designed before in the world using permanent magnet generator, variable speed generators, and allow fish to pass through the generators without harm. And I'll talk to you a little bit more about that in a minute on another opportunity that we're doing right now. But that's what it takes today to, as far as innovation, to try to get this type of technology into today's world. And unfortunately, this is fully designed, but we're not going for construction because we cannot get a contract for that. So that's the way it is. So after $22 million and a lot of model testing, proving the technology, proving the powerhouse operation, proving the fishway operation, 40 years of research and development, and we're sitting here waiting. So I just want to talk to you a little bit more about, let's see how I'm doing my time here, not too bad. Clean energy innovations. And I firmly believe that private industry will flourish if we provide a predictable, fair, and long-term policy framework. And I think this is one thing that is really lacking in Canada today, and something that really needs to be thought through in depth. And I'm going to give you an example of how industry has reacted to some of these opportunities in jurisdictions where it has those qualities. We have about 80,000 structures that look just like that in North America. They control outlets of lakes, they are on irrigation canals, they're on navigation canals, they're throughout the entire country's fabric. We do not have a commercially viable hydro technology that can capitalize on a 1 to 4 meter drop to a structure like that. And therefore, they are simply there as water control structures. What we've developed is a new turbine that is a little bit different. the technology exists, it's just a matter of whether or not it was commercially viable. The traditional approach is a siphon cap and turbine, where you build a big powerhouse like this, big generator, put in a runner like that, and the water goes through here. Very capital intensive, a lot of structural components. The next choice is this, which is more of the Dunvegan design with if you picture a submarine with an extra large propeller on the back, that's what that turbine is. And that's an actual bolt turbine. And the generator is encapsulated right in the flow, and that's what cools the generator during operation. You still need a very large structure, as I showed you on the other slide, to create the drop in the structure and manage the flow. What I'm talking to you now is about the very low head turbine, or the VLH turbine. And this part, the hatch part here, is the existing structure, so you're not building the structure. You're simply putting in a turbine which has a generator built within it, all in one. And we're doing experimentation with that turbine right here in the basement of this building for the next 2 years. It was developed, the idea was conceived here in Canada, but because of the way that the government and the policies are in this country, it was deemed that it was not going to be able to be developed here, so we ended up developing it in France. And we worked with some French designers, and we came up with this design, and we're now bringing it back to Canada this year. We started in 2004, and we basically have a holistic design where this is a turbine, a generator, a gate, a trash rack, a fish passage, and a lift system all in one. And there it is in its operating position, and then in its maintenance or flood passage position in an existing structure. And what we've had the first turbine in operation now for 4 years. We have 22 units deployed now in France, Italy, and Belgium. And here's pictures of the turbines, the very first turbine that was deployed in Millau, France. And you may know Millau is the highest bridge in the world, is located over that city. And we're within about a kilometer of that bridge at this location. And this turbine is a permanent magnet generator. It operates at variable speed. That's what gives it very high efficiency, because that's what double regulates the cap and turbine. It articulates these blades and also varies its speed to gain the efficiencies. The advantage is that it only operates at 35 RPM, and it has very large passage openings, so the fish can swim right through without any harm. We've done 2 sets of fish tests now. The last fish test we had was 100% zero mortality. So 100% fish passage without any problems. So that's why we're wanting now to bring it into Canada, because we think this is the kind of technology we need for the future. So for installation, a typical hydro project today takes about 3 years to get permitted, another 2 years to build. My very first hydro project, which is the Belly River in southern Alberta, it took 3 months to get permitted and 9 months to build. So I think we're going the wrong direction in some things. But the same thing is that with this type of technology, it takes about 3 months to do the modification of the structure, and about a week to install the unit and a week to commission. Now they're only 0.5 megawatt in size, and you say, okay, how are we ever going to get enough volume of energy from these types of installations? And this is not the solution for everything. It is one of the solutions that we have available. And 80,000 structures with only capturing maybe a few percentage of those for this type of installation, we literally have thousands of megawatts that can be generated using this type of technology. Some of the structures that we're working on right now are on the Mississippi, where 60 or 70 of these turbines will be installed at each one of the locations. So there it is in the down position without the water backed up, and there it is in the operating position, and all you see is this little bit extra over the existing structure. And it's fully silent, it just makes the sound of the running water. Now what we're doing at UC is we're perfecting the cold climate adaptation package here. And in France they don't have frozen rivers, here we do. So we've been doing work with Enercan and NSERC and developed the methods of dealing with that here in Canada. And that's what we're moving towards now. So that's the end of my talk. And I thought that might give you a bit of an insight of what it takes to do hydropower and renewable energy development in Canada today. And